question is, what can you say about the range of a rational function? Now, remember that a rational function is a quotient of polynomials, p of z over q of z, and that if we apply the division algorithm for polynomials, we can always write this as s of z plus t of z over q of z, where s of z and t of z are also polynomials, and further, the degree of t is less than or equal to the degree of q. While we're at it, we might as well suppose that these polynomials are in lowest terms, meaning that there is no factor of this, there is also a factor of that, or vice versa. In other words, there was no time that this one is 0 and that one is 0 simultaneously. Okay, so what can we say about the range? Well, the range of a polynomial is the values, or the range of a rational function, rather, is the values that it can take. So we ask a question, can we solve r of z equals lambda? If we can solve this, then lambda is in the range, and if we can't, lambda is not in the range. So, what can we say about that? This is the same as saying that p of z over q of z is equal to lambda, and that is the same as saying that p of z minus lambda q of z is equal to 0. Now, p of z and q of z are polynomials, so this is a polynomial. If this is a non-constant polynomial, it has a solution. So if this is a non-constant polynomial, there is a z so that this is true. So there is a z so that r of z is equal to lambda, and lambda is in the range. On the other hand, if this is a constant polynomial, and the constant is not 0, then there are no solutions at all. And I suppose if the constant were equal to 0, it would actually mean that p of z and q of z were multiples of each other, so they wouldn't be in lowest terms. So, let us consider p of z minus lambda q of z is equal to a constant where constant c is not equal to 0. In this case, we can write, dividing through by q of z, r of z, which is equal to p of z over q of z, is equal to lambda plus c over q of z. Now, if this is really a rational function, rather than a polynomial, q of z is not constant, so this is not a constant polynomial. So, in this case, what can we say? In this case, this happens exactly when we do the polynomial division. Here, there is a constant, and here, there is a constant that is not 0. So, what else can we say? Let's try to summarize things. So, how can we summarize neatly? So, the range of R is equal to the whole complex plane unless R of z is equal to lambda plus constant over q of z, where lambda is a complex number and c is a complex number, but it's not equal to 0. And in this case here, then the range, if this is the case, there's only one way in which we can write this. We wouldn't be able to write r of z as equal to two different constants plus a constant over q of z, because, for instance, if I take the limit of this as z goes to infinity, q of z goes to infinity, c over q of z goes to 0, the limit of this, in this case, at infinity, as z goes to infinity, is lambda. There's only one possible value of lambda. So, in this case, we can say that the range of R is equal to complex plane minus